So looking at some more balance situations, we know because the balance scales are balanced across from each other that they're equal. You're looking at this situation, you're saying, okay, there's some number, a variable n is an unknown, that's being added to 3 apples, and over here you have a total of 2, 4, 6, 7 apples. Now this isn't that hard of a problem. You could look at it and you could go, well, geez, if I start taking some of these apples away, they'll be fair. If I start taking this apple away and this apple away, it's going to be fair. And if I take that apple away, I got to take one more apple away, and everything's fair. I took the 3 apples away from both sides, and I have n is equal to 4. The plus sign isn't needed because I took everything away from it. So therefore, n must equal 4. Now some of you might say, I can do that. I don't need you to move apples around. I get it. This is a pretty easy problem. I just wanted to demonstrate the concept. You're not always going to have balance scales. You might just have an equation. So we want to talk about how to write those as equations as well. More balancing scales, this time no apples. Alright, I would suggest that you not get carried away and you change this to plus -7. So you have a t, you have an unknown value that's being added to a -7, and it's coming out to a +4. You've got to think inverse. What's the opposite of that -7? Because my objective is to isolate this variable. I want to get t completely alone. And the only way I can get t alone is if I get rid of -7. The only way I can get rid of -7 is if I have the opposite of a -7. So what is the opposite of -7? A +7. Alright, so if I give a +7 to this side, then that +7 and this -7 are going to cancel out. But it wouldn't be fair to this balance scale if I only gave +7 to the left. I have to do the exact same thing and give +7 to the right. I must keep things fair. What I do to one side, I must absolutely do to the other. Now, these 7s and -7s cancel out, so they're gone. And I'm left with just plain old t. I've isolated. Therefore, t now equals 11. Now you can go back to the original problem and test it out. If you had 11 and you added -7 to it, or you had 11 and you subtracted 7, 11 minus 7 is 4. It still works. So you've got to be careful. A lot of people subtract 7 from both sides, and they end up with a -3 as an answer, and then it just doesn't work. All right? One more situation. Now this one's a little trickier. There's a lot of mistakes that are made on this one. People see this subtraction sign right here, and so they instantly think, well, the opposite or the inverse of subtraction is addition. So I'm going to add 9, and I'll add 9. And they come up with 16. They're like, yay, I got it, because that's the opposite of subtraction. Try it out. See if you got the right answer. It only takes a moment to test your answer and see if it works. Stick 16 right here, and 9 minus 16. Ooh. 9 minus 16 would be -7, not +7. So apparently this is not correct. So I need to be very careful. This is a very common mistake. Let's take it back to the beginning. First of all, I would probably suggest that you make this plus -h. Alright? Now you don't want to get rid of a -9 like before. You actually want to get rid of a +9. And the only way to get rid of a +9 is if you add a -9. Because +9 and -9 are opposites. And so when they add together, they will create 0. So over here you have to add -9. You can add those two together, and you can add these two together, which means they cancel out. And you're left with -h. Don't forget it was negative, we changed it. Is equal, because remember they were equal to begin with, 7 plus -9 is -2. Now if you stop right now, you won't quite have the answer. You're almost there. Notice that this says -h. We aren't actually interested in solving for the negative of a variable. We want to solve for the positive version. But all I got to do to make it positive is switch its sign. And remember, be fair. If you do something on one side, you have to do it to the other. If I'm switching sign here, I got to switch the sign over there, which means h is equal to 2. Now let's try that out. Go back up to the original. 9 minus 2 is 7. Oh, it seems so simple. Of course that's the answer. But people end up with answers like 16 and -16 all the time because they don't watch their signs and they're not sure how to handle it. Be very careful when it says minus the variable. That's a situation where this was probably going to take place. So let's look at some without any balance scales and see if we can solve these problems. All right, we've got 9 is equal, or x minus 9 is equal to negative 17. We would like to get variable x completely alone. I would make the adjustment to plus negative 9 right there. And now our objective is to get the x alone. We've got to get rid of a negative 9. So what is the opposite of a negative 9? The opposite is a positive 9. But if you just do that and you cancel out and go x equals negative 17, you will have the wrong answer. The rule states, whatever you do to one side of the equal sign, whatever you do to one side, you must do to the other. So if I add 9 here, I have to add 9 here. And this is where your addition of positive and negatives comes into play. X now equals, you have 8 more negatives than you do positives. It will take only a moment for you to plug this answer back in and check it in your head. Negative 8 plus negative 9 is in fact negative 17 because negatives plus negatives makes more negatives. Please show these steps. Practice showing this work of what you do to one side, you do to the other. Do not do the solving in your head, no matter how easy the problem is. Attempt to show the work. The checking of your answer, by all means, you can do in your head. All right, another example. This is one of the reasons I would strongly recommend that you watch your signs. If you don't change them, here's a very typical mistake that gets made. You just got to be careful. People see the negative 2 and they think, oh, I'm going to add 2. And they add 2. Those cancel out and they go, negative 9's the answer. But if you go back to the beginning of this problem and you try negative 9 out, would negative 9 minus negative 2 actually equal negative 11? Not if you went plus positive. It would end up equaling negative 7, which means negative 9 clearly is not the answer. So let's go to the very beginning of this problem and instead switch our subtraction to plus the opposite. It's now this problem. Alright? So this leads to another mistake that people make, and another reason why I suggest you add negatives. People see the plus 2 and they go, well, the opposite of adding 2 is to subtract 2. And you're right, the opposite of adding 2 is to subtract 2, but a very common mistake is people come over here and then they go, oh, well, negative 11 minus 2, that makes negative 9. Or maybe they think positive 9, but some version of a 9. Again, if you tried that out, negative 9 plus a positive 2 would give you negative 7. Not the answer we're looking for. So if you go back to where I messed up, and I say, well, what's the opposite of a positive 2? I would say add a negative 2. Because a positive 2 and a negative 2 are still going to cancel each other out. But the benefit is on the other side. If I do this exact same thing over here and I add negative 2, I have those rules already established which state that when you add negatives to negatives, you get more negatives. Now try it out. If you have negative 13 and you add a positive 2, you have 11 more negatives. It's going to work. But you got to be willing to change some signs at the beginning, and that takes practice. You can't get good at this stuff by looking at it for a couple minutes. Right? We would like to get x alone. So to get x alone, don't pay attention to that positive so much as what is this right here. This is a positive 5. So again, people will make the mistake. They'll subtract 5. But in subtracting 5, they end up with a negative 2 or a positive 2 or some version of a 2. You've got to resist that urge and use your adding of the opposite. A positive 5 being added to a negative 5 will still cancel out. But I'm far less likely to make my mistake on the other side. These cancel out. X now equals negative plus negative makes more negative. Very different answer than a positive or a negative 2. 5 plus negative 8, yep, 3 more negatives. And our last one, be very careful. This one, a very, very common mistake is people see the subtraction, so they add 4. And they add 4. And they think the answer is n equals 7. But if you go back to the original problem, 4 minus 7 equals 3. Nope, doesn't work. You can't see that subtraction and apply it to the 4. This is a positive 4. You got to get rid of a positive 4. So I would make that plus negative n. To get rid of a positive 4 requires that you add a negative 4 so that they're opposites of each other. Now what you do to one side you must do to the other. So the 4 and the negative 4 cancel out. You have negative n. 3 plus negative 4 is negative 1. But we don't want negative n. We want positive n. So if you change the sign to a positive on one side, you have to change whatever the sign is on the other. If this had been negative n equaled positive 7, and I changed it to positive n, I'd have to make it negative 7. whatever you have on this side is going to change on the other as well, whatever it is. Alright? So please practice each one of these steps where what you do to one side you do to the other. Actually write it on each side of the equal sign. You can do the testing by plugging it back in because 4 plus negative 1 is 3 or 4 minus 1 is 3. It works when you plug it back in, but don't be afraid to practice showing the work first.